51. A plane is on a flight path that will take it directly over a lake on its path to the airport. The angle between the pilot and the runway center is 45 degrees, and the angle between the pilot and the lake center is 65 degrees. What is the distance between the centers of the lake and the airport? So they are looking for this distance right here. So we're looking for x. And if I'm going to use this triangle right here, if this is 65 and this is 45, then inside is going to be 20. And I know that if you have a triangle, if you don't have a right triangle, SOHCAHTOA is not allowed, but I'm going to be thinking law of sines or law of cosines. And if you know more information about the sides than you do the angles, we're going to use the law of cosines. So automatically D and E can be crossed off. So law of sines is out. Law of cosines, if you recall, is c squared equals a squared plus b squared minus 2ab cosine c. And we are going to let, since we're looking for this angle across from the side across from the angle, this is going to, x gets to be our c actually. So we're going to have x squared equals a squared. It doesn't really matter which one you let be a and which one you let be b. So 320 squared plus 360 squared minus 2 times 320 times 360 times cosine of the angle, which is 20 degrees. And now you'll notice if I looked at those to get rid of the square, we're just going to square root. And then I just look at, notice I don't have to simplify it, I just have to look at which one matches, and the one that matches is B. All right, number 52. If A and B are any real numbers, with B being bigger than 1, which is bigger than A, which is bigger than 0, which of the following must be true for all values of A times B? So me looking at this, I know that B is bigger than 1, and then when I look at right here, this shows me that A is between 0 and 1. Okay, so I know I'm going to multiply A times B together. So if I multiply B times a number that's smaller than 1, I'm going to get a number that's going to be less than B. So my answer is going to be less than B. But and then when I multiply A by a number that's bigger than 1, I'm going to get a number that's bigger than A. So I just need to look at which product gives me a number that's less than B, but it's bigger than A, and it's going to be choice G. Right, 53. For all triangles ABC, where angle ABC is larger than angle BAC, which of the following statements is true? And they are giving me all sorts of things about side lengths, so I'm going to draw the triangle and see if I can figure out what's going on. So we've got triangle A, B, C. So let's figure out what angle they're talking about. Angle ABC is going to be this angle right here, and then angle BAC. BAC is going to be this one right here. Okay, they say that this one is bigger than this one, so I'm going to put bigger and smaller, right? And then I see that they give me some things about side lengths. Well, you know, if the angle's bigger, the side is going to be bigger, so side AC is always going to be bigger than side BC. So side AC will always be bigger than side BC, so I'm going to see if there's a choice like that, and there definitely is. Choice E says the length of side BC, whoops, did I do that? I did that backwards. Side, no, I didn't. Yes, I did that correctly. They just wrote the problem funny. The side length of BC is always less than the length of the side AC, because AC is always going to be bigger, so I was right. Okay, so my choice is E. Right, 54. What is the smallest positive integer that leaves a remainder of 1 when divided by all three of the integers 8, 12, and 18? Well, this one I decided just to go with my choices and just see which was the smallest one that worked. So I started with 25, and I'm going to, when I put 8 into 25, goes in 3 times, and I have a remainder of 1, so that works. Then I'm going to put 12 into 25. 12 goes into 25 2 times, and once again I get a remainder of 1. And then I'm going to put 18 into 25, and that only goes 1 time, and that gives me a remainder of 7. So 25 does not work, so let's try 37. All right, 8 into 37 would go in, let's see, 4 times, remainder of 5. That already does not work, so let's try 41. We'll put 8 into 41. 8 goes into 41 5 times. We get a remainder of 1. So far, so good. So let's try 12 into 41. 12 goes into, let's see, 3. It's going to give me 36. That gives me a remainder of 5. So we get to stop there. Let's try 73. So 8 goes into 73 9 times. I'll get a remainder of 1. 12 goes into 73 6 times. We get a remainder of 1. This might be it, folks. And then 18 into 73 actually goes in 4 times, and we get a remainder of 1. So this is the smallest one that has a remainder of 1, choice J. All right, 55. For all non-zero values of m and m, the square root of m over the square root of m plus the square root of n equals, right? If you're not sure how to work this problem, pick a value for m, maybe 2, and n, 3, plug it in, and then plug them in each of the choices until you get an equivalent answer. But hopefully from the work with calculus, you remember that when you see something like this, we can multiply by the conjugate and probably get to something that's going to work out quite nicely. So in the numerator, we're going to distribute that square root of m to both sides. The square root of m times the square root of m is just m, and then minus the square root of m times the square root of n is just going to be the square root of m n. And then over, if we FOIL the denominator, the insides and outsides are going to be canceled out, so I'm just going to be left with the square root of m times the square root of m, which is m, and then minus the square root of n times the square root of n is n. So then if I look at which choice that is choice C. But again, you could just as easily get it by plugging in values for the m and the n. All right, 56. If box x squared equals 2 times box x, then find box 100, given that box 10 is equal to 1. All right, I just kind of played around with this one a little bit, and this is what I found. I just put the 100 and the 10 in for my 2 little boxes there. So I had x squared equals 2 times x, and so then I put 100 equals 2 times 10, and so then I'm looking for box equals 2 times, I know that this is equivalent to 1, so then I just figured 2 times 1 was equal to 2, so that box would be filled with 2, which is a K. Right, 57. Of the 30 students in a class, 20 took the test during the class and 10 took it after school. The average score for the in-class testers was 60. The after-school testers averaged 90. What is the class average? So class average means adding all the people's scores up and dividing by how many people took the test. So there were 30 people that took the test. 20 of them took it during class, and their score was 60. So I'm going to put 20 times 60 because that was their average, and then plus we had 10 people that took it after school, and their test was 90. All right, so if we work that out, we'll do 20 times 60 plus 10 times 90, and then we'll divide that result by 30, and we should get 70, which is choice B. Okay, 58, which is a possible value for cotangent theta if sine theta is equal to 3/5. Well, first of all, hopefully you remember that cotangent is equal to the cosine of theta over the sine theta. The next thing that we need to do is try to find, we know the sine theta, we just don't know cosine, so I'm actually going to draw a triangle here. Okay, and we know that sine is opposite over hypotenuse, so this will be 3 over 5. And if you use SOHCAHTOA or you're familiar with your special triangles, this side is going to be 4. So I would like the cosine of theta, so the cosine is adjacent over hypotenuse, so the cosine is going to be 4/5, and the sine we already know is 3/5. So if I multiply by the reciprocal, the 5's cancel out, we end up getting 4/3 as our answer, which is choice J. Right, 59. Which of these expressions is equivalent to negative x squared plus 1? Again, if you did not remember how to factor, the easiest thing is just pick x equals 2 or something like that, find this answer, and then plug x equals 2 into all their choices until you get one that is equivalent. I prefer to write this as 1 minus x squared, because if I do, then it looks like a difference of squares, so this would be 1 plus x times 1 minus x, and if I look at which choice that matches, although they wrote the x plus 1 backwards, that's okay because addition is commutative. It is choice A. All right, last one. A geometry student made the measurements of the figure below. In order to use them to find the width of the pond, which of the following would be most applicable? So it is not a right triangle, so we can't use properties of special triangles or the Pythagorean theorem. And let's see, we're looking for this side. We want the width of the pond. We want this side. I do notice that I have two angles, and I know a side across from this one. I'm looking for this side. I could easily find this angle. So since I have more angles than I do sides, the law of sines is always the one we want to choose. So it's going to be choice J.